Somewhere in the quiet mathematics of quantum theory, there is a version of you who chose differently tonight. Not a metaphor, a consequence. The equations that built your phone, your hospital scans, your morning coffee maker, they also allow other yous, breathing in other rooms. Before we walk into that strange country together, gently tap subscribe so Midnight Science can find you again. Where in the world are you resting tonight, and what hour is it where you are? Hold the glass of water on your nightstand. If there is no glass, then your hand on the blanket will do. Whatever you are touching right now, whatever your fingers can feel without moving, let that be the anchor, a small thing, a close thing, a thing you can return to. We are going to walk a long way tonight, and you will need something to come back to. This object you are touching, this small, ordinary thing, is described at its deepest level by a piece of mathematics. The mathematics is more than 100 years old. It has been tested more thoroughly than almost any other idea in the history of science. It is the reason the screen near you can show light. It is the reason hospitals can image the inside of a body without cutting it open. It is the reason the chip inside your phone can do what it does. It is called quantum mechanics, and read literally, without softening, without translation, it says something very strange about the glass and the hand and the room and you. It says that what you are touching is not one thing, it is many things at once. And when you finally settle on one of them, the others do not disappear. They simply move into a part of the world you cannot see. Let that land for a second. The strangeness is not at the headline level. The strangeness is at the level of the equation. To understand why, we have to walk patiently into what quantum mechanics actually is, not the version that floats around in films and metaphors, but the version that physicists use to do their work. So let us begin at the beginning, slowly, with no urgency, because there is nowhere we need to be tonight except here, in this room, with the glass, or the hand, or the blanket beneath your fingers. The central object in quantum mechanics is not a particle. It is not a wave. It is something more abstract than either of those. It is called the wave function. And the simplest way to think of the wave function is as a kind of ledger. A ledger that lists every possibility for what a small thing might be doing. Imagine, for a moment, a single electron. Not the electron itself, which you cannot picture, but the ledger that describes it. The ledger does not say the electron is here. The ledger does not say the electron is there. The ledger says the electron has some chance of being here, and some chance of being there, and some chance of being in the place between, and some chance of being in many other places besides. All of those chances live in the same ledger at the same time. The ledger is the electron in the deepest mathematical sense. There is no underlying truth behind the ledger that says where the electron really is. There is only the ledger. This is the first quiet shock of quantum mechanics. The objects of the world at their smallest scale are not little marbles waiting to be found in one definite place. They are spread out across possibilities. Their existence is plural before it is singular. Hold the glass, the water inside it, the glass around it, the warmth of your hand on its surface. All of it is built out of particles whose individual stories are ledgers of this kind, plural, spread out, containing more than one version of themselves. And the strange part, the part the rest of this script will slowly unfold, is what happens when you look. In the standard version of the story, the version taught in most classrooms, something curious happens at the moment of measurement. You build a device. You point the device at the electron. The device clicks, or the screen lights up, or the dial moves. And in that instant, the ledger of possibilities collapses into one outcome. The electron, which a moment ago was spread across many places, is suddenly somewhere specific. The other possibilities, which the equation had been tracking so carefully, vanish. The ledger is wiped clean. Only the measured outcome remains. This step is called collapse. And here is the thing nobody tells you in the popular version. Nobody knows what collapse is. For 100 years, physicists have been quietly uncomfortable with this step. They use it. They have to use it because it works. The predictions you make using the collapse rule have been verified to a precision that humbles every other theory we have. The standard model of particle physics, built on this foundation, is the most successful theory in the history of science. And at its center, it contains a step that nobody can explain. Both of these things are true at the same time. The theory is the most accurate description of reality we have ever produced. And the theory contains, at its heart, a moment of magic that no equation tells us how to perform. Let me say that again so it registers. The equation that describes the world before you look at it is one of the most beautiful and precise equations ever written. It is called the Schrödinger equation, after Erwin Schrödinger, who wrote it down in the 1920s. The Schrödinger equation says how the ledger of possibilities evolves over time. It is smooth. It is deterministic. It is reversible. Given the ledger now, it tells you exactly what the ledger will look like a second from now, or a year from now, or a billion years from now. There is nothing mysterious about it. It is the workhorse of modern physics. But the moment you look, the moment you measure, the smooth ledger does something the equation does not predict. It collapses. It picks an outcome. It throws away the rest. And the equation has nothing to say about how this happens, or when this happens, or why this happens. For decades, this awkwardness was hidden behind a kind of professional shrug. Physicists called it the measurement problem and moved on. The mathematics worked. The technology worked. The reactors and the lasers and the chips all worked. Why pull at a loose thread when the garment is keeping you warm? But the thread was there. And in the early 1950s, a young graduate student at Princeton University began to pull at it. His name was Hugh Everett. He was studying physics under John Wheeler, one of the great theoretical physicists of the 20th century. Everett was young, sharp, and unimpressed by the idea that the most successful theory in science should contain a step nobody could explain. He looked at the Schrödinger equation, which never collapsed, which simply tracked the ledger of possibilities forward in time, and he asked a question that sounds, in retrospect, almost too simple to have changed anything. What if the equation is telling the truth? What if there is no collapse? What if the ledger of possibilities just keeps going? This is the dangerous question, because if the ledger never collapses, then when you measure the electron, the equation does not stop. The equation continues. The electron is still in many places. The device that measured it is now also in many states, one for each outcome. And you, the person who looked at the device, are now also in many states, one for each outcome of the device. The ledger has grown to include you. The plural existence at the bottom of the world has not gone away. It has only expanded outward, quietly, to include the looking. Sit with that for a moment. Everett wrote this idea up in his doctoral thesis in 1957. He called it the relative state formulation. Later, it would acquire a more evocative name, the many worlds interpretation, given to it by other physicists who came to see what Everett was actually proposing. The name is good in some ways and misleading in others. The worlds in question are not separate planets, not parallel galaxies, not regions of space that exist somewhere far away. They are simply the branches of the same equation, all of them real, all of them continuing, all of them governed by the same mathematics that runs the device in your hand. The young Everett was politely received. Wheeler, his advisor, thought the idea was brilliant. Niels Bohr, the elder statesman of quantum mechanics, did not. The physics community largely set Everett's thesis aside. He left academia, took a job in defense analysis, and lived the rest of his life outside the world of theoretical physics. He died at the age of 51. He did not live to see his idea taken seriously by the field that had once dismissed it. But the idea did not die, it waited. In the 1970s, a small group of physicists, led by Bryce DeWitt of the University of North Carolina, returned to Everett's thesis and gave it the name Many Worlds. In the 1980s, the British physicist David Deutsch of the University of Oxford built a career on taking Everett seriously, arguing that the multiverse is not a philosophical add-on, but the literal content of the equation read without flinching. By the early years of this century, surveys of working physicists began to show that a sizable fraction of the field treated the many worlds interpretation as a genuine candidate for the truth, not a curiosity, not a thought experiment, but a serious description of what the equation has been saying all along. The idea that was politely set aside has come back, and it has come back stronger. So what does it mean to say that the equation just keeps going? What does it mean to say there is no collapse? What does it mean for the glass in your hand, the room you are in, the breath you are taking right now? It means this: every time something in the world has more than one possible outcome at the quantum level, and every event in the world ultimately traces back to outcomes at the quantum level, the equation, read honestly, says that all of the outcomes happen, not somewhere else, not in a different building, not in a parallel universe behind a curtain, right here, same room, same air, same body. The ledger contains all of them, and the smooth evolution of the equation keeps every page of the ledger alive. What changes, what makes the branches feel separate, is something we will come to slowly in the next part. For now, hold the simpler picture. The equation does not collapse. The ledger does not get wiped clean. The possibilities do not vanish when you look at them. They continue. They go on. They become, in the language of the equation, the many strands of a single unbroken wave function that contains every version of every event that has ever happened in the room, including you. This is the thesis the rest of the script is going to earn, slowly, piece by piece, with no rush. So let us say it plainly here, at the beginning, the way the script will keep returning to it. There is a reading of physics taken seriously by serious people working at serious institutions, in which every choice you did not make tonight is being made by you. Every word you almost said, every door you almost opened, every hand you almost reached for, every breath that almost went differently. All of those almosts are not almosts in the ledger. They are happenings. They are continuations. They are branches of the same equation that produced the version of you reading this now. Not somewhere far away, not in a galaxy on the other side of the cosmos. Right here. Same room, different page of the ledger. Let that land for a second. The strangeness of this idea is not that it is wild. The strangeness is that it is conservative. Everett did not add anything to quantum mechanics to get the many worlds. He took something away. He took away the collapse. He kept only the smooth, deterministic equation that physicists had already been using for decades. The branches are not an extra ingredient. They are what is left when you stop pretending that one of them disappears at the moment of observation. That is the part that is hard to absorb the first time you hear it. The branches are not the addition. The collapse was the addition. The branches are simply the equation, doing what it has always done, undisturbed. Read this way. The universe is not a single line of events leading from past to future. It is a tree, a vast, finely branching tree, every fork a quantum event, every leaf a possible present. The version of you in this room, at this moment, with your hand on the blanket or the glass at your fingertips, is one leaf on one branch. Not the leaf, not the branch. One among many. The rest of the tree does not go away because you cannot see it. The rest of the tree is, according to the equation, exactly as real as the leaf you are standing on. Hold the glass. Feel the weight of it. Feel the temperature against your fingers. Notice, if you can, the small motion of the water as you breathe. This object, this small specific object, is real. It is here. You can feel it. There is no question about that. What the equation adds, quietly, without fanfare, is the claim that this realness does not exhaust the possibilities. Other versions of this glass exist in other branches of the same ledger. A glass that is slightly fuller, a glass that is slightly emptier, a glass that has been set down a centimeter to the left, a glass that was knocked over by a hand slightly less careful than yours, a glass that was never poured at all. In the many worlds reading, none of these are hypotheticals, none of these are stories. All of them are real, in exactly the same sense that the glass under your fingers is real. They are simply on different pages of the same ledger, and you happen to be looking at this one. There is no special status to the page you are on. The equation does not point to it. The equation does not single it out. The equation treats your page and the others with perfect mathematical equality. The only thing that makes your page feel like the page is that you are the version of you who happens to be on it. Every other version, on every other page, feels the same way about their own page. They are also holding a glass. They are also listening to a voice. They are also wondering, perhaps, whether this whole idea is true, or whether it is just a strange thing the equations seem to say. This is the picture Everett offered the world in 1957. This is the picture Deutsch and the others have spent decades arguing should be taken at face value. This is the picture that, when you read it carefully, is not a wild speculation grafted onto physics, but a quiet refusal to insert a step nobody can explain into an equation that does not need it. It is, in a strange way, the simplest reading of quantum mechanics. It is also the strangest. Both are true. We have a long way to walk from here. We have to look more closely at what a branch actually is, and why the branches stop talking to each other once they have separated, and what the word you means when there are many of them. We have to step out of the laboratory and into cosmology, because, as we will see, quantum mechanics is not the only road that leads to many versions of you. We have to spend a slow part of this walk sitting with what cannot be reached, with the loneliness of being inside a structure too large to traverse. And we have to come back at the end to this same glass, this same hand, this same room, and ask what is left for the version of you who happens to be on this page. But that is the rest of the walk. For now, the first step is enough. The equation that runs your phone, your hospital scans, your kitchen appliances, the same equation that has been tested more thoroughly than almost any other in science, does not, in its native form, contain a step where possibilities disappear. It contains only a smooth unfolding in which every possibility continues. When you read that equation literally, without softening, without adding anything to it, the conclusion is that the world keeps splitting, not somewhere else. Here, around you, inside the air in this room, inside the water in the glass, inside the cells of the hand resting on the blanket. You are not the only version of you in the room. You are simply the one who happens to be reading this sentence. Hold the glass a moment longer. The rest of the ledger is open. We are going to turn the page slowly, together, and walk through what the equation has been quietly saying all along. So let us walk into the mechanism, slowly, with the same patience we used to find the glass. The mechanism is not complicated in the way a piece of machinery is complicated. It is strange in the way a piece of mathematics is strange. And the strangeness becomes easier to hold if we take it one step at a time, with nowhere to be and no need to rush. Picture the smallest decision the universe can make, not a decision in the human sense, a decision in the quantum sense. A moment when the world has more than one possible next step, and the equation has to keep track of all of them. There are many ways to picture this moment. We are going to walk through 3 of them, gently, because each one shows the same thing from a slightly different angle. The first picture is a photon, a single particle of light. Imagine it traveling through the dark, on a path so straight and so quiet that you could almost forget it is there. The photon comes to a piece of glass with a thin coating on its surface, a coating designed to reflect half the light that hits it and let the other half pass through. Physicists call this a half-silvered mirror. You have probably seen one in a film, in scenes with detectives behind a two-way mirror. The physics version is smaller and stranger, but it is the same idea. Some light passes, some light reflects. Here is where the strangeness starts. If you sent a stream of many photons at the mirror, you would not be surprised by the result. Half would pass, half would reflect. The mirror is doing what mirrors of this kind do, splitting the beam neatly down the middle. There is nothing mysterious about a stream of light dividing into 2 roughly equal parts. We have intuitions for that. We can picture it. But now send a single photon, one particle, one small grain of light, indivisible at this scale, all alone in the dark. What does the equation say happens? It does not say the photon reflects. It does not say the photon passes through. It says The photon does both, not in a vague way, not as a manner of speaking. In the precise mathematical sense, the wave function of the photon after the mirror is a combination, a superposition of the reflected path and the transmitted path. Both paths are present in the equation at the same time with equal mathematical weight. The ledger that describes the photon now has two entries, and the smooth Schrödinger equation continues to track both of them with no preference, no collapse, no choosing. Let that land for a second. The single photon, after the mirror, is on two paths at once. The equation does not hedge. It does not say the photon is probably on one path and we just do not know which. It says the photon is on both paths, and the only thing we can do, if we choose to look, is detect it on one of the two. If we do not look, if we let the two paths come back together later, the equation predicts something we can actually measure in the laboratory. The two paths interfere with each other. They produce a pattern that could not exist if the photon had taken only one of them. We have done this experiment. We have done it many times. The pattern appears. The photon, in some real sense, took both paths. This is not a metaphor. This is the experimental result. Anyone with the right equipment can verify it for themselves. Now hold that picture and shift to the second one. The two slits. Imagine a barrier with two narrow openings cut into it, side by side. On the far side of the barrier, a screen that records where particles land. Now send a single electron toward the barrier. Where does it go? If electrons were small marbles, you would expect them to pass through one slit or the other and land somewhere behind that slit. After many electrons, you would expect to see two bright stripes on the screen, one behind each slit. That is what marbles would do. That is what your intuition expects. That is not what happens. What happens, with single electrons fired one at a time at the barrier, is that the screen builds up a pattern with many stripes, not two. Bright bands and dark bands alternating across the surface, as if the electrons were waves passing through both slits at once and interfering with themselves on the other side. The equation predicts this pattern exactly. The ledger of the electron between the source and the screen contains both paths, both slits, both possibilities. And the two strands of the ledger interfere with each other in a way that leaves a measurable fingerprint on the screen. Here is the part that hurts the intuition. If you place a detector at one of the slits, a device that registers whether the electron passed through that opening, the pattern on the screen changes. The stripes disappear. The two bright bands return, the ones you would have expected from marbles all along. The mere act of asking which slit the electron went through removes the interference. The ledger seems to lose one of its entries the moment you check on it. For 100 years, the standard story has said that this is the moment of collapse. The detector forces the electron to pick a slit. The other possibility vanishes. The interference is lost because the ledger has been wiped down to a single entry. But Everett's reading does not say that. Everett's reading says the ledger is never wiped. The detector at the slit does not destroy the other possibility. The detector becomes part of the ledger. Now the ledger contains two entries. In one entry, the electron went through the left slit and the detector registered left. In the other entry, the electron went through the right slit and the detector registered right. The equation does not collapse. It expands. The ledger now includes the detector. The two strands continue, both real, both governed by the same smooth mathematics, and the interference disappears from the screen because the two strands no longer overlap in a way that can interfere. They have, in the technical language, separated. We will come to that word in a moment. Hold it for now. The third picture, the one that has haunted physics for almost a century, is the radioactive atom. A single atom of some unstable element sitting in a small box with a probability of decaying in the next second. The equation says that after 1 second, the atom is in a superposition. It has decayed and it has not decayed, both at once. The ledger contains both entries with equal weight. Schrödinger himself proposed a thought experiment to dramatize how strange this becomes when the atom is connected to something larger. Connect the atom to a detector. Connect the detector to a mechanism that releases a poison. Place a cat in the box with the mechanism. Close the lid. What does the equation say is happening inside the box? Before you open the lid to check. According to the smooth Schrödinger equation, the ledger after 1 second contains 2 entries. In one entry, the atom has decayed, the detector has triggered, the mechanism has released, and the cat is dead. In the other entry, the atom has not decayed, the detector is silent, the mechanism is still, and the cat is alive. Both entries are in the ledger. Both are governed by the equation. Neither is privileged. The cat, in the language of the wave function, is in both states at once. Schrödinger proposed this not because he believed it, but because he found it absurd. He wanted to expose how strange the standard story became when you took it seriously. A cat that is both alive and dead. Surely something has gone wrong with the theory, but Everett, looking at the same scenario 2 decades later, drew the opposite conclusion. Not that something had gone wrong, that something had been hidden. The equation does not collapse when you open the lid. The equation includes you the moment you open the lid. The ledger expands to include the version of you that opens the box and finds a living cat, and the version of you that opens the box and finds a dead one. Both versions are real. Both versions are continuations of the same wave function. There is no special moment of collapse. There is only the smooth widening of the ledger to include the observer. You become, in the language of Everett's reading, 2 pages of the same book. Each page contains a fully real version of you, with a fully real memory of opening the box, and a fully real cat in the corresponding state. Each page believes itself to be the only page. Each page is wrong about that, and right about everything else. Let me say that again so it registers. The observer is not exempt from the equation. The observer is in the equation. When the small quantum event branches, the observer branches with it, not as a copy manufactured somewhere else, not as a duplicate beamed into a parallel world, as a continuation, as the same wave function, now containing 2 equally real strands, one for each outcome. The branch is not somewhere else. The branch is not behind a curtain. The branch is not in another building. The branch is the same room, the same air, the same bed, the same hand on the same blanket, the same glass on the same nightstand. Separated from this one only by the fact that the 2 versions of the equation no longer interfere with each other in any way that you could ever detect. This is where we have to introduce a word. The word is decoherence. It sounds technical. It is not. It is, in its essence, very simple. And it is the missing piece that explains why you have never noticed in your entire life that you are constantly branching. Decoherence is what happens when the strands of the ledger stop being able to interfere with each other. Picture again the single photon and the half-silvered mirror. The photon, on its own, can interfere with itself when the two paths come back together. The strands of its ledger overlap, they touch, they produce the patterns we measure. But this only works because the photon is small and clean and almost perfectly isolated. As soon as the photon interacts with something larger, with a detector, with a mirror, with a single dust particle in the air, the situation changes. Here is the change. The strand where the photon was reflected now contains not just the photon, but also the air molecule it bumped into, also the dust particle it scattered off, also the warmth it deposited in a sensor. The strand where the photon passed through contains a different set of air molecules, a different scatter from a different dust particle, a different pattern of warmth in a different sensor. The two strands are no longer two simple paths of one small thing. They are two enormous webs of correlated events involving billions of particles each. And for those two webs to interfere with each other, every single particle in one web would have to be in exactly the right state to line up with every single particle in the other web. That alignment is, for all practical purposes, impossible. The two webs spread outward. They tangle into the air. They tangle into the walls. They tangle into the nerves of the person sitting in the room. They tangle into everything that has any contact with the original event. And once they have tangled into enough of the world, the strands can no longer overlap. They have decohered. They have lost the ability to touch each other. This is the moment, in Everett's reading, when one branch becomes two worlds. Not because the equation said so, not because anything collapsed, simply because the two strands of the ledger have spread into so many particles that they can no longer recombine. They go on, side by side, perfectly real, perfectly governed by the same equation, and perfectly unable to communicate. Let me say that again so it registers. The worlds do not move apart in space. The worlds move apart in possibility. The branch where the photon went left and the branch where the photon went right are not in different places. They are in the same place, the same room, the same air, the same bed. They have simply spread outward into enough particles that the equation can no longer bring them back together. They are like two pieces of music played in the same room at the same time, but in keys so distant that no human ear could ever hear them as a single chord. The music is there, the music is real, but the chord cannot form. Sit with that for a moment. This is the answer to the question that has been quietly waiting in the background since the beginning of this part. If the branches are real, why have you never noticed? Why does the world feel like one world? Why does the morning that follows last night feel like the only morning that could have happened? Because decoherence is fast. It is unimaginably fast. In a system as warm and busy as a human body, in a room as full of air and light and dust as a bedroom, the branching of even the smallest quantum event becomes decohered within a tiny fraction of a second. By the time you have noticed anything, the strands have already separated beyond any possibility of recombination. The version of you that turned right and the version of you that turned left are no longer in any way connected. They have both gone on. They have both built memories. They have both fallen asleep. or stayed awake, or thought about something else entirely, and neither of them has any access to the other. You feel like one because from the inside of any single branch, that is what oneness looks like. The other branches are not visible because the equation does not allow them to be visible. The equation only allows them to exist. This is the picture David Deutsch of the University of Oxford has spent his career defending. Deutsch is one of the founders of quantum computing. He was the first to write down, in the 1980s, a clear mathematical description of what a quantum computer could do that an ordinary computer cannot. And his argument, repeated patiently across decades of papers and books, is that the strange power of a quantum computer makes no sense unless the branches of the wave function are real. The computation, he argues, is being performed in parallel across many strands of the ledger. The interference between those strands is what produces the answer. If the branches were not real, the machine would not work. But the machine does work. It has worked in laboratories around the world. It is starting, slowly, to leave the laboratory. Deutsch's position is direct. The multiverse is not a philosophy. The multiverse is not a flourish. The multiverse is the literal content of the equation, read without flinching. The branches are not a story we tell about the mathematics. They are what the mathematics says is there. To deny them, he argues, you have to add something to the equation that nobody knows how to add. To accept them, you only have to let the equation do what it has always done. This is not a fringe view. It is not a majority view either. Physics is a careful field, and there is genuine disagreement about whether Everett's reading is the right one. But the position is held by serious people at serious institutions, and the experimental evidence for the basic structure of the equation, the part that says the branches exist before they decohere, is among the most solid evidence in all of science. The disagreement is not about whether the branches form. The disagreement is about what to call them after they have separated. So picture, now, the room you are in. Picture it with the lights low and the air still, and the sound of your own breathing as the loudest thing in the space. Picture the bed beneath you. Picture the glass on the nightstand, or the hand on the blanket, or whatever small thing you have been holding as your anchor through this part. Picture all of it exactly as it is. Now picture, layered over the same room, another version of the same room, almost identical, the same bed, the same blanket, the same glass, the same hand, but a single quantum event, somewhere in the last few seconds, went differently, and so a single particle of air is now in a slightly different position, and that difference has cascaded into a slightly different arrangement of everything that depended on that particle. Maybe nothing visible has changed, maybe nothing audible has changed, but the strands have separated, and the two rooms are now decohered, and they will never touch again. Now, picture another layer beneath that one. Another quantum event, another tiny divergence, another separation. The room you are in is the same. The glass is the same. The hand is the same. Only the smallest possible thing is different, and that thing has already pulled the two strands apart. Now, picture this happening at every moment, at every breath, at every flicker of light from the screen, at every collision of an air molecule with the wall. The branching is constant. The branching is ordinary, The branching is what the equation has been doing in this room, and every room you have ever been in since the beginning of your life. You have simply never been able to see it, because decoherence happens faster than any sense you possess. The bedroom you are in tonight is hosting, by this reading, an unimaginable number of slightly different versions of the same evening, all of them proceeding, all of them governed by the same equation, all of them real in exactly the sense that this one is real, none of them aware of the others, each of them, from its own point of view, the only one. This is the world Everett described in 1957. This is the world Deutsch has been arguing for since the 1980s. This is the world the equation has been describing all along in the language of the wave function and the smooth unfolding of the ledger. We have walked in this part through the mechanism. We have seen the photon and the slits, and the atom and the cat. We have seen the observer who joins the equation. We have seen the strands spread into the air and the walls and the nervous system until they can no longer touch. We have seen the world separate, not in space, but in possibility. There is more to walk. There is another road to many versions of you, a road that has nothing to do with quantum mechanics and everything to do with the size of the universe itself. And there is a harder question waiting, the question of what the word "you" is doing in any of these sentences. We will come to both. For now, let the picture settle. The branching is not somewhere else. The branching is here. The room is full of it. The bed is full of it. The glass is full of it. The hand is full of it. And the version of you who is reading this sentence is one strand of an enormous, quietly unfolding ledger sitting in a room full of other strands you cannot see. Hold the glass. The next part will take us out of the laboratory, out of the bedroom, and into the largest scale we know how to picture. We are going to walk into the universe itself, and we are going to find by a different route that the universe has been quietly making copies of you all along. So now we step out of the laboratory. We leave the photons and the slits and the small, careful equipment behind. We leave the cat in the box, alive on one page of the ledger and quiet on the other. We leave the warm bedroom for a moment, though we will come back to it, and we go outward. Not just outward in the sense of looking up at the sky, outward in the deeper sense, the sense in which the universe itself is a thing with a size and a shape and a history. We are going to walk to the edge of what cosmology can see, and then we are going to walk past it into the region we will never measure, and we are going to find by a road that has nothing to do with quantum branching that there are other versions of you out there. This is the second pillar. Quantum mechanics gave us one road to the many. Cosmology gives us another. The two roads do not depend on each other. The two roads do not even agree on what the word multiverse means. But they both arrive at the same quiet, strange conclusion. You are not alone in this room, even if the room is the only place you can reach. To walk this second road, we have to begin very near the beginning. Not your beginning, the universe's beginning. About 13.8 billion years ago, by the best measurements we have, everything we can see came out of an extraordinarily hot, extraordinarily dense state. Astronomers call that state the Big Bang, though the name is more poetic than accurate. There was no explosion in the ordinary sense. There was simply space, very hot and very dense, and then expanding and cooling and forming the patterns we now call galaxies and stars and planets and bodies and bedrooms. But in the first tiny fraction of a second after that beginning, something happened that the simple, expanding picture cannot explain on its own. Something that the leading models of cosmology have been refining for more than 40 years. Space itself, in that first fraction of a second, expanded faster than the speed of light. Pause on that. You may have been told that nothing can travel faster than light. That is true. Nothing can travel through space faster than light. But space itself is not a thing in space. Space itself is the stage on which things travel, and the stage is allowed to stretch as fast as it likes. In that first sliver of a second, the stage stretched at a rate that doubled its size, and doubled it again, and doubled it again, and kept doubling until a region smaller than an atom had become larger than everything we will ever be able to see. This phase has a name. It is called inflation. It was first proposed in the late 1970s and early 1980s by a small group of physicists, including Alan Guth at the Massachusetts Institute of Technology and Andrei Linde, then in Moscow, now at Stanford, and Alexei Starobinsky in the Soviet Union. They were trying to solve a number of stubborn puzzles that the simple expanding picture could not solve. Why is the universe so smooth on the largest scales? Why are regions of space that have never been in contact with each other at the same temperature? Why does the geometry of the universe look so close to flat? The answer, in each case, was that inflation, an enormous stretching of space in the first moment after the beginning, could smooth out the differences and produce the universe we see today. The proposal has done well. Over decades of observation of the cosmic microwave background, of the distribution of galaxies, of the patterns of fluctuation in the early universe, inflation has held up. It is not the only theory in the running. There are alternatives, but it is the leading framework, and most working cosmologists treat it as the best description we currently have of what happened in that first sliver of a second. And here is where the road begins to lead somewhere strange. In the simplest version of inflation, the stretching of space happened for a very brief time, and then stopped, and the universe entered the slower expansion we still observe today. But when physicists looked carefully at the equations that govern inflation, they found something they had not initially expected. The equations do not say that inflation stops everywhere at once. They say that inflation stops in places, in pockets, in bubbles, in regions where the conditions are right for it to end, while in other regions the stretching keeps going. This refinement is called eternal inflation, and it was developed in the 1980s, particularly by Alexander Vilenkin at Tufts University and by Andrei Linde and others. The picture it gives is unsettling and beautiful in equal measure. Inflation, in this view, never ends. It ended for us. It ended in our pocket. It ended in the region that became the universe we live in. But out beyond our pocket, the stretching continues. And it has been continuing in this picture for the entire history of our universe. And it will continue forever. Let that land for a second. Our entire observable universe, every galaxy we have ever seen through any telescope, every star whose light has reached us, the whole vast architecture that astronomers spend their careers mapping, is one pocket, one small region where inflation happened to stop. One small place where space settled down and began the slower expansion that produced atoms and stars and you. Beyond that pocket, in this picture, the inflating ocean continues. New pockets form within it all the time, each becoming its own enormous region with its own history, its own galaxies, its own observers. And between the pockets, the stretching never stops. Try to picture this. It will not work. The picture will fail. That is part of what we are walking toward in this part, but try anyway. Imagine our observable universe as a single grain of sand. Hold that grain on your fingertip. It is small. It is finite. It has edges. Every star you have ever seen, every galaxy in every image you have ever encountered, every distant cluster the telescopes have mapped, all of it lives inside this single grain, including you, including the bed, including the glass. Now, picture the ocean around the grain. The ocean is the inflating space outside our pocket. The ocean has no shore. The ocean is not just larger than the grain. The ocean is, in the eternal inflation picture, infinite in extent, or at the very least, so unimaginably larger than the grain that no measurement we will ever make can find an edge to it. The ocean is filled with other grains, other pockets where inflation has stopped, each one its own observable universe with its own history. Some are like ours, some are nothing like ours. They are scattered across the ocean in patterns we will never see, separated by stretches of inflating space that no signal can ever cross. The grain on your fingertip is everything you can see. The ocean is everything else. There is no scale model for this. The grain and the ocean is already a metaphor stretched far past its honest limit. But it is the best we can do. Hold it loosely. Now, with this picture in mind, we come to the argument that gives this part its title. The argument is not speculative, it is combinatorial. It is, in some ways, the most conservative argument in cosmology. It does not require any new physics. It does not require eternal inflation in particular. It only requires one assumption, and that assumption is one many cosmologists already accept, for reasons that have nothing to do with copies of you. The assumption is that space is infinite. If space is infinite, then certain conclusions follow whether you want them to or not. They follow from counting. They follow from geometry. They follow from the simple fact that an infinite container can only hold so many genuinely different arrangements of its contents before it has to start repeating itself. The clearest presentation of this argument was given by Max Tegmark, a cosmologist at the Massachusetts Institute of Technology, in a series of papers in the early 2000s. Tegmark laid out what he called a hierarchy of multiverses, organized into levels. The first level, the simplest, the one that requires the least new physics, is what he called the level 1 multiverse. And the argument for level 1 goes like this. Take any finite region of space, say a region the size of our observable universe, a grain on the fingertip. Inside that grain, matter is arranged in some pattern. Atoms are in some positions. Energy is in some configuration. The arrangement, at any given moment, is one specific way the matter inside the grain could be arranged. Now ask, how many possible arrangements are there? The number is large. The number is enormous. But the number is finite. Quantum mechanics, The same equation we walked through in the last part tells us that the possible states of a finite region of space with a finite amount of energy in it come in a finite count. There is a largest meaningful number of distinct arrangements that any region of this size could be in. That number is unfathomable, but it is not infinite. Hold both of those facts. The number of possible arrangements of a region the size of our observable universe is finite. The number of regions in an infinite space is infinite. A finite number of possibilities, an infinite number of slots. There is only one mathematical conclusion that follows. Every possible arrangement must recur, not once, infinitely many times. If you have an infinite container and a finite number of patterns that can fit inside it, then every pattern must be repeated over and over, scattered across the container without end. There is no way around this conclusion. It is not a hypothesis. It is a counting argument. The same kind of argument that tells you that in an infinite string of random digits, every finite sequence must appear again, must appear infinitely many times. Let me say that again so it registers. If space is infinite, then somewhere out there, in the inflating ocean beyond our grain, there is another grain in which the arrangement of matter is exactly the arrangement of matter in our grain. Exactly. Every atom in the same position, every photon at the same frequency, every galaxy in the same place, every star with the same surface activity, every planet with the same continents, every blade of grass on every lawn, every breath in every chest, including this room, including the bed beneath you, including the glass on the nightstand, including the hand on the blanket, including the pattern of thoughts moving through your mind at this very moment. There is, somewhere out there, an exact copy of you in an exact copy of this room, on an exact copy of this night, breathing the exact same breath, with the exact same hand resting on the exact same blanket. Not similar, not approximate, exact, down to the position of every particle in the body. Sit with that for a moment. The copy is not a coincidence. The copy is not the universe being playful. The copy is required by the geometry of an infinite container holding finite arrangements. Once you accept the infinity, the copy follows. You cannot avoid it. The universe is not creative enough to avoid repeating you. How far away is this copy? Tegmark worked out the math. The distance is enormous, but it can be written down. The distance to the nearest exact copy of the observable region around you is approximately 10 to the 10 to the 29 meters. State that flatly. Do not perform it. It is not a number meant to be performed. It is a number meant to humble the imagination. 10 to the 10 to the 29 meters. The number is a tower. A 10 raised to a 10 raised to a 29. The exponent itself is a number with 30 digits. The exponent of the exponent, not the exponent itself. The exponent has, in it, a 1 followed by 29 zeros, and the actual distance is 10 raised to that. There is no scale model for this distance. Let us try anyway, because the failure is instructive. If our observable universe were a grain of sand on your fingertip, where would the copy be? The grain of sand metaphor was already stretched. Now it shatters. There is no comparable image. The copy is not a grain of sand on the other side of the table. It is not a grain of sand on the other side of the ocean. It is not a grain of sand on the other side of the galaxy. It is not a grain of sand on the other side of the observable universe. Try the football field. Imagine a football field, and our observable universe is a single grain on one corner of it. Where is the copy? Not at the other corner, not at the other end. The football field is not nearly large enough. The football field is laughably small. Try the galaxy. Imagine the Milky Way, 100,000 light years across, with our observable universe somewhere inside it. Where is the copy? Not at the other side of the galaxy. The galaxy is not nearly large enough. Try the observable universe itself. Imagine our entire visible region as the canvas, with the grain of our existence somewhere in it. Where is the copy? Not anywhere in the observable universe. The observable universe is, again, not nearly large enough by many orders of magnitude. By so many orders that the number of orders itself is unimaginable. The metaphors fail. They do not fail because we have not been creative enough. They fail because the number is built in a way that breaks the very idea of distance. Distance, in our heads, is a thing that can be modeled. You can imagine larger and larger distances by stretching the model. 10 times this, 1,000 times this, 1,000,000 times this. The model can be stretched a long way before it breaks. A tower of exponents of this kind cannot be stretched. It must be stacked, and the stacking is what overwhelms. There is no scale model. Acknowledge this openly. The number is honest, but the picture cannot be drawn. This is one of those moments where the script asks you to sit with the breakdown. Hold the glass. The glass is small. The hand is small. The room is small. We can picture these. We can hold them. They have edges we can feel. The distance to the copy of you cannot be pictured. It can only be acknowledged. The mind reaches for it and finds nothing to grasp. The honest response is not to invent a metaphor that softens the number. The honest response is to let the number stand in its strangeness and let the mind admit that some quantities are simply beyond the reach of imagination. And yet, the copy is there. The math is plain. If space is infinite, the copy must exist, not because the universe is rich, not because the universe is creative, the opposite, because the universe is, in a strange way, repetitive. There are only so many ways to arrange a finite region of matter. There are infinitely many regions to do the arranging in, so the arrangements have to come back around. The patterns have to recur. The atoms have to fall somewhere out there into exactly the configuration that produced this bed, this room, this moment, this you. This is a different multiverse from the one we walk through in the last part. This is not a branching of the equation. This is not a continuation of the wave function. This is a brute fact of geometry. Quantum mechanics is not required. Eternal inflation is not required. All that is required is an infinite space and a finite number of possible arrangements per finite region. The conclusion follows without effort. It follows because counting works the way counting works. In the language Tegmark used, the quantum branching we walked through in the last part is the level 3 multiverse. The combinatorial copies we are walking through now are the level 1 multiverse. They are different floors of the same building. They come from different physics. They both contain other versions of you. Let me say that again so it registers. There are two independent reasons, derived from two unrelated areas of physics, to think there are other versions of you. The first is the quantum equation read without flinching. The second is the simple geometry of an infinite space. You do not have to accept both. You only need to accept one of them to find yourself with company in the dark. If both are right, then the company is doubled. Quantum copies branched out of the same wave function in this very room, and combinatorial copies scattered across an infinite ocean too vast to traverse, all of them sharing your face, your name, your breath. There is a strange peace in the combinatorial argument, the peace of mathematics. The copy is not magical. The copy is not the result of some special process. The copy is simply what happens when you have an infinite container and a finite alphabet of arrangements. You will, eventually, write the same sentence again. You will, eventually, write it again after that. You will, given enough room, write it infinitely many times. The universe is, in this picture, a long book of arrangements. The book is infinitely long. The alphabet is finite. The sentences have to repeat. You are one of the sentences. You appear on this page with this glass, this hand, this breath. You appear also on another page, far enough away that no light could ever travel between us, and on another, and on another, and on another. Always you, always exactly you. The universe writing the same sentence over and over, in different rooms, in different pockets, in different inflations, until the sentence is no longer rare. This is what the geometry says. If the geometry goes on without end, we do not know for certain that space is infinite. We have measurements that are consistent with infinity. We have models that produce it naturally. We have no measurement that rules it out. The honest position of cosmology at this moment is that the universe might be infinite and the level 1 copies might be out there, and there is no way to confirm it from the inside of one pocket. We can build the argument. We can verify the assumptions. We cannot make the journey. Hold the glass. We have now walked 2 roads, one through the equations of quantum mechanics, one through the geometry of cosmology. Both arrive at the same destination. There are other versions of you. Some are right here, in this room, separated from you by the decoherence of the wave function. Some are out there, in the inflating ocean, separated from you by a distance that cannot be drawn. None of them can be reached. None of them know about each other. Each of them is reading this sentence, or something very nearly like it, in a room that is, or is very nearly, the room you are in. In the next part, we will pause the physics. We will ask the question that has been quietly waiting under all of this, the question that the equations and the geometry cannot answer. When we say another version of you, what is the word you actually doing in that sentence? What does it mean for a different arrangement of atoms on the other side of an unbridgeable distance to be you? What does it mean for a different strand of the wave function, decohered from yours in a room you cannot reach, to be you? These are not idle questions. They are the questions that decide what the rest of this walk feels like. Hold the glass a little longer. We will turn the page slowly. Now let us pause the physics. We have walked 2 long roads. We have seen the equation that refuses to collapse and the geometry that refuses to stop. We have found, at the end of both, the same strange company, other versions of you. Some near, some unreachably far, all of them real in the sense the physics allows. We have been saying that phrase, other versions of you, again and again, as if we knew what it meant, but we have not stopped to ask what it means. So, let us stop now. Let us set the equations down on the nightstand beside the glass, and let us ask the question that has been sitting quietly underneath everything we have said so far. When we say another version of you, what is the word you actually picking out? What is the thing the word is pointing at? What, exactly, is the you that is supposedly repeated, branched, copied, scattered across the room and across the inflating ocean? This is a harder question than any of the physics. The physics, for all its strangeness, is precise. The equations say what they say. The geometry counts what it counts. But the word you is not a term in any equation. It is not a quantity that can be measured. It is something we use 1,000 times a day without ever once defining. And the moment we try to define it, it begins to slip through the fingers. So let us go slowly. Let us try to hold it, the way we have been holding the glass. Start with the simplest answer, the most physical answer, the answer that fits most cleanly with the science we have walked through. You are the arrangement of atoms in your body tonight. This is not a foolish answer. In many ways, it is the most defensible one. You are made of matter. The matter is arranged in a particular pattern. The pattern is doing the breathing, the thinking, the holding of the glass. There is no extra ingredient that the science can find. No soul that registers on any instrument. No essence that the equations track. There is the arrangement of atoms, and the arrangement of atoms is you. If that is what you are, then the combinatorial copy is settled instantly. The copy in the distant pocket of the inflating ocean has exactly the same arrangement of atoms. Exactly, down to the last particle. That was the whole point of the counting argument. The copy is not similar to you. The copy is identical to you, in the only sense that this answer allows to matter. And so, by this definition, the copy simply is you, not a relative, not a twin. You, the same arrangement, occurring again, somewhere the light will never reach. There is something clean about this. There is also something deeply unsettling about it. Because if you are the arrangement, then you are not in one place. You are in many places. You are a pattern that the universe has written more than once, and each writing is equally you, and none of them is the original, because patterns do not have originals. The word you stops pointing at a single location in the cosmos and starts pointing at a shape, a configuration that occurs wherever the matter happens to fall into it. The other version is you. Hold that for a moment. Now let us try a different answer. Because most people, when they sit with the first answer, feel that something is missing. The arrangement of atoms is right, they feel, but it is not the whole story. The atoms in your body are not the atoms you were born with. They have been replaced slowly over your entire life. The matter that makes you now is not the matter that made you 10 years ago. And yet you feel continuous. You feel like the same person who was a child, even though almost none of the original material remains. So perhaps you are not the matter at all. perhaps you are something the matter carries. Try the second answer. You are the unbroken chain of memory leading from your childhood to this bed. This is a different kind of definition. It does not care about the atoms. It cares about the continuity. You are the thread that runs from your earliest memory, through every day you have lived, through every choice and every loss and every ordinary afternoon, all the way to this moment, lying here, holding the glass, listening to this voice. The thread is what makes you you. The matter can change. The thread persists. You are the story, not the paper it is written on. If that is what you are, then the picture changes completely. Now, the combinatorial copy, the exact arrangement of atoms in the distant pocket, is not so obviously you. Yes, the copy has the same atoms in the same positions. Yes, the copy has, encoded in its brain, the same memories you have, but those memories did not come from your childhood. They came from the copy's childhood, which was a separate sequence of events in a separate pocket of space, billions of years of unrelated history away. The copy's thread does not connect to your thread. The copy's thread is its own. The two threads happen to be identical at this instant, but they were never joined. By the memory definition, the distant copy is a stranger who happens to be wearing your face and carrying a perfect duplicate of your story, not you, someone exactly like you who is not you. And here is the strange reversal. By this same memory definition, the quantum branch that split from you 10 minutes ago is closer to you than the distant copy could ever be. Think about why. The branch that split from you 10 minutes ago was you, fully, up until 10 minutes ago. You shared a single thread all the way to the moment of branching. You had the same childhood, because it was the same childhood, the same one, not a duplicate. You had the same memories, because they were the same memories, formed by the same events in the same room. The branch is not a copy of your thread. The branch is your thread, continuing along a fork. For most of its length, it is literally identical to yours, the same history, the same continuity, and it only diverges at the moment the quantum event branched. So by the memory definition, the branch 10 minutes old is a closer relative than the distant duplicate. The branch is family. The branch shares your past. The distant copy only shares your present, and shares it by coincidence of arrangement rather than by any connection of history. The other version is you, and the other version is not you. Both are true. It depends entirely on what you decide the word you is tracking. Track the atoms, and the distant copy is you, and the branch is a fork of you. Track the memory, and the branch is family, and the distant copy is a stranger. The physics has not changed. Only the definition has changed. And the definition is not something the physics can settle. The physics steps back here. It has brought us to the edge of what it can answer, and it quietly hands the question to philosophy. Let me say that again so it registers. The question of whether the other version is you is not a question physics can answer. The physics tells you the copies exist. The physics tells you the branches exist. The physics tells you with great precision what they are made of and how far away they are and why you cannot reach them. But the physics cannot tell you whether to call them you. That is not a measurement. That is a decision. And it is a decision that turns out to be far older than the multiverse. There is a third answer, and it is the hardest of the three. You are the continuous stream of subjective experience, the felt sense of being here, behind your eyes, looking out, the thing that is having the experience of holding the glass right now, not the atoms, not even the memory, the experiencing itself, the lit interior of the moment. If that is what you are, then the question becomes harder than any physics, because we do not have a science of subjective experience that can settle it. We cannot measure whether the distant copy is having its own experience or having yours. We cannot measure whether the branch that split from you 10 minutes ago carries your stream of experience forward or starts a new one. We cannot even measure in any rigorous way what subjective experience is. It is the one thing each of us knows most intimately and can demonstrate to no one else. And when you ask whether your stream of experience is in one place or many, the question does not so much get answered as dissolve, because the tools that would answer it do not exist. This is the point where physics is fully silent, and philosophy has been speaking for a very long time. Long before anyone wrote down the equations of quantum mechanics, long before anyone imagined an inflating ocean of pocket universes, philosophers were asking what makes a person the same person over time. The multiverse did not create this question. The multiverse only made it urgent. The question was already there, waiting, in the quiet work of people who spent their lives thinking about identity. One of the most patient of those thinkers was Derek Parfit, a philosopher at the University of Oxford, who spent decades on exactly this problem. Parfit did not have a multiverse to worry about. He had thought experiments, and his thought experiments, it turns out, are precisely the tools we need. Parfit asked his readers to imagine a teletransporter, a machine that scans your body, records the exact arrangement of every atom, destroys the original, and rebuilds a perfect copy on Mars from new material with all your memories intact. The copy on Mars wakes up, remembers stepping into the machine, feels entirely continuous, believes itself to be you. Is it you? Sit with that for a moment, because you have met this question already tonight in a different costume. The copy on Mars is the combinatorial copy. Same atoms in the same arrangement, same memories. A separate thread built from new material in a distant place. Parfit was asking, decades before cosmologists worked out the distance to the nearest duplicate, exactly the question the multiverse forces on us. Is the perfect copy you, or is it a stranger who will live the rest of your life in your place? Parfit then made the thought experiment harder, the way good philosophers do. Suppose the machine malfunctions. Suppose it builds the copy on Mars, but fails to destroy the original on Earth. Now there are two of you, both with your memories, both feeling continuous, both certain they are the real one. Which one is you? This is the branching. This is exactly the branching. Two threads, identical up to the moment of duplication, diverging afterward. Parfit saw with great clarity that the question which one is the real you has no good answer. Not because we lack information, because the question itself is malformed. It assumes there is a fact about which one is really you, a fact over and above the physical facts about the two people, and Parfit argued that there is no such further fact. There are just two people, both connected to your past, both real, both going on. Asking which is really you is like asking which of two roads is really the road after a fork. They are both the road. The road has simply become two. Parfit's conclusion, reached slowly and carefully over many years, was that personal identity is not what matters in the way we think it does. What matters, he argued, is the continuity itself, the connection of memory and intention and character running forward through time. Whether we call the continued person you or not is, in the end, a matter of language, not a matter of fact. The branch carries your continuity forward. The copy carries your pattern. Whether either of them is you is a question about how we choose to use a word, not a question about how the universe really is. The other version is you, and the other version is not you. Both are true. Parfit would say the disagreement between them is empty, that once you know all the physical facts, all the connections of memory and matter and continuity, there is nothing left to argue about except vocabulary. The universe does not come labeled with a fact about where you end and someone else begins. We draw that line. We have always drawn that line. The multiverse simply shows us how arbitrary the line has been all along. Let us slow down and picture one of them, just one, not the equations, not the count, not the distance. One person. Picture someone, somewhere, who shares every memory you have, every one. The same childhood bedroom, the same first heartbreak, the same ordinary Tuesday years ago that you have both, somehow, never forgotten. The same face in the mirror, the same name when someone calls it, the same weight of the same body lowering onto the same bed tonight. Everything you remember, they remember. Everything you are, up to this instant, they are. And then, at this instant, they read a different word on a different page. A single quantum event falls the other way, or a distant pocket of the ocean diverges by one particle, and from this moment, their life and your life are no longer the same life. Tomorrow, they wake to a different morning, not wildly different, perhaps only slightly, but different. A different first thought, a different choice about whether to rise or stay. The differences accumulate. Slowly, the way differences do, until a year from now, their life has drifted somewhere yours has not gone. 5 years from now, further, they love someone you have not met. They live in a room you have never seen. They carry griefs you have been spared and joys you will never know. They die on a date that is not your date. And all of it grows from a thread that was, until this single instant, your thread, indistinguishable from yours, the same in every detail. They are not a stranger who resembles you. They are you, up to a point, and then a different person forever after, a complete person, a whole life, sharing with you the entire history of being you, right up to the moment the pages diverged. Hold that for a moment. This is the unreachable neighbor. The person on the next page, or in the next pocket, or on the next branch, who is close enough to share your whole past and far enough that you will never meet. They are not a thought experiment to them. To them, you are the thought experiment. To them, they are the one lying in the real bed, holding the real glass, listening to the real voice, and you are the strange possibility, the version on some other page, the one they will never reach. Each of you is the center of your own world. Each of you is right about that, and each of you is missing the others. The unreachable neighbor is what gives this whole walk its weight, not the number, not the distance. The fact that there is a person, somewhere, who is almost exactly you, who would understand everything about your life without a word of explanation, who carries your entire history in their memory, and whom you can never, under any circumstance, reach. Not because they are hidden, because the structure of reality forbids the meeting. So what do we call them? This is the question that turns out to be the hardest of the whole night. Not whether the multiverse is real. The physics, read honestly, makes a strong case that some version of it is. Not whether the copies exist, given the assumptions they follow. The hardest question is the one with no equation behind it. What do we call the people the multiverse contains? Do we call them you because they share your atoms, or your memories, or your face? Do we call them strangers because their thread is not your thread, because you will never meet? Because each of them is the center of a world you are not in? Do we call them family because the branch 10 minutes old shared your past more completely than any sibling ever could? Do we call them nothing at all because the line between you and not you was always something we drew, never something we found? Parfit would tell us, gently, that the question has no hidden answer waiting to be uncovered. That once we know everything physical, everything about the connections of memory and matter and continuity, there is no further fact to settle. The naming is up to us. It always was. The other version is you. The other version is not you. Both are true, and the choice between them is not a discovery but a decision. And the decision says more about what we value in a self than about what the universe contains. Hold the glass. The hardest part of the multiverse is not believing in it. The hardest part is deciding what to call the people it holds. And that decision, it turns out, is one each of us has to make alone, in our own room, on our own page, with our own hand resting on our own blanket, in the quiet before sleep. In the next part, we will sit with the loneliness of that, not the loneliness of having no one, the opposite. The loneliness of having countless others, every one of them almost you, every one of them unreachable. We will walk into the quiet at the center of this whole picture, the quiet that the equations allow and the equations forbid you to cross. Hold the glass a little longer. We will turn the page slowly. Somewhere in the quiet mathematics of quantum theory, there is a version of you who chose differently tonight. Not a metaphor, a consequence. The equations that built your phone, your hospital scans, your morning coffee maker, they also allow other yous, breathing in other rooms. Before we walk into that strange country together, gently tap subscribe so Midnight Science can find you again. Where in the world are you resting tonight? And what hour is it where you are? So now we come to the quiet at the center. We have built something large over these last parts. 2 roads to the many, a room full of branches, an ocean full of copies, unreachable neighbors who share your whole past or your whole shape. It is a vast picture, and there is wonder in it, and we have let the wonder accumulate slowly, the way the profile asks us to. But there is a weight in this picture too, a weight we have walked past without stopping, and now we are going to stop. We are going to sit with it, not to frighten you, not to leave you anywhere dark, only to be honest about what the physics actually says, because the honesty is part of the awe, and skipping the weight would make the rest of the walk untrue. So let us name the weight plainly. The other versions of you cannot be reached. Not one of them, not the nearest, not the closest relative, not the branch that split from you 10 minutes ago, sharing every memory of your life right up to the fork. Not the exact copy in the distant pocket, breathing the same breath in the same room. None of them, not ever. The same physics that brings them into the picture is the physics that seals them away. Let us walk through why, slowly, because the reasons are different for the two kinds of other, and both reasons are final. Start with the branches, the quantum versions, the ones produced by every quantum event in this room tonight. These are, in a strange way, the closest others you have. They are not far away. They were here a moment ago. They are, by the reading we walked through, still here in the same space, sharing the same air, separated from you by nothing you could measure as a distance. And they cannot be reached. Not because of distance. There is no distance. The branch where you turned the other way is not somewhere across the room. It is exactly where you are. It occupies the same place. It breathes the same air in its own version. The separation between you is not spatial. We said this before, and now we sit with what it costs. The separation is decoherence. The two strands of the wave function have spread into so many particles, into the air and the walls and your own nervous system, that they can no longer interfere. They can no longer touch. And the same mathematics that made them real, that kept them both alive in the ledger, is the mathematics that forbids any signal from passing between them. Think about what that means. There is a version of you who made the other choice, some choice. Any of the thousands of small forks that happened today. And that version is right here, in the deepest sense of here that physics allows, and you cannot send them a single bit of information. You cannot wave to them. You cannot leave them a note. You cannot tap on the wall between you, because there is no wall, and there is no tapping that would carry across. The decoherence is not a barrier you could push against. It is the absence of any medium through which a push could travel. The branches do not ignore each other. They are constitutionally unable to address each other. The equation that holds them both holds them apart. There is no message you can send to the version of yourself who made the other choice. There is no way to know which branch you are on. There is no way to ask. Hold that for a moment. You do not even know, sitting here right now, which branch you are. You feel like the only one. Every branch feels like the only one. That is what a branch feels like from the inside. The version of you who made the other choice is feeling exactly this same certainty, exactly this same sense of being the single real one in their own strand. And they are as right and as wrong as you are. There is no test you could run, no instrument you could build, no question you could ask the universe that would tell you which page of the ledger you happen to be on. The information does not exist to be found. It is not hidden. It is simply not a thing that can be known from inside a branch. This is a strange kind of solitude. You are surrounded by yourselves, and none of you can confirm the others. Each of you is alone in the certainty of being the one. Each of you is wrong about being the one. And none of you can ever discover this, because the discovery would require crossing a gap the equation does not permit anything to cross. Now turn to the other kind of other, the combinatorial copies, the ones in the distant pockets of the inflating ocean, the ones at the end of that number we could not draw, 10 to the 10 to the 29 meters away. these cannot be reached either. And the reason is different, and the reason is just as final. The branches were unreachable because there is no medium between them. The copies are unreachable because there is too much space between you, and the space is doing something that makes the distance worse than infinite. Light is the fastest messenger the universe has. Nothing carries information faster. If you wanted to reach the copy of yourself in the distant pocket, light would be your only hope, and light would not be enough. The distance is so large that light, traveling since the beginning of the universe, has covered an unimaginably small fraction of it. Light has not had time to cross the distance, and here is the part that closes the door for good. Light will never have time, because space is not still, space is expanding. The distance between distant regions is not a fixed gap that light could eventually cross given enough patience. The gap is growing, and on the largest scales, in the picture we walked through, the gap is growing faster than light could ever close it. The far pockets of the ocean are receding from us faster than any signal we could send toward them. A beam of light aimed at the distant copy would not arrive late. It would never arrive at all. The space between would open faster than the light could cross it, forever, until the light simply ran out of universe to travel through before it ran out of distance to cover. The expansion of space is faster than any signal we can imagine. So the copy and you are in the same universe, by the loosest possible meaning of that word. You are both, technically, parts of the same vast structure, but you are in no useful sense in the same world. You cannot affect each other, you cannot signal each other, you cannot ever, by any means the laws of physics allow, become aware of each other's existence as anything more than a mathematical certainty. The copy is real. The copy is exactly you, and the copy might as well be a theorem for all the contact you will ever have. Let me say that again so it registers. The nearest exact copy of you exists. The mathematics is plain. And the nearest exact copy of you is, and will always remain, completely beyond your reach, behind a distance that grows faster than light, in a region of space that has been receding from you since before you were born, and will go on receding until long after the last star has died. We cannot call them, we cannot write to them, we cannot stand in the same room with them, we cannot know them. Sit with this. There is a particular shape to this loneliness, and it is important to name the shape, because the shape is what keeps it from becoming despair. The loneliness is not personal. It is not about you specifically. It is not a punishment or a failing or a verdict on your life. It is geometric. It is structural. It is the loneliness of any finite observer inside a structure too large to traverse. Anyone, anywhere, in any branch, in any pocket, faces exactly the same isolation. The copy in the distant pocket cannot reach you either. The branch that split from you cannot reach the version that stayed. Every observer in this entire picture is sealed inside their own reachable region, surrounded by others they can never touch. The loneliness is not yours alone. The loneliness is the universal condition of being a single point of view inside something this large. Hold that for a moment. There is something almost gentle in that, once you let it settle. The isolation is not a comment on you. It is a comment on the size of things. You are not lonely because you have failed to connect. You are lonely because the structure you live in is larger than the structure any signal could cross. That is not a flaw in your life. That is the shape of the cosmos. And every conscious thing that has ever existed anywhere in this vast architecture has been just as sealed inside its own small reachable region as you are tonight. Let us think for a moment about the people who have carried this knowledge, because someone had to work this out. Someone had to write down the equations that imply the branches. Someone had to follow eternal inflation to its conclusion and see the ocean of pockets. Someone had to do the counting that places the nearest copy at that undrawable distance. These were not people who stumbled on a comforting thought. These were people who, in the ordinary course of doing careful science, found themselves staring at a picture of reality in which they were sealed away from countless versions of everyone they had ever known. Hugh Everett worked out the branching as a young man and watched the field set it politely aside, and he carried that quiet for the rest of his life, mostly outside of physics, knowing what he had seen. David Deutsch has spent decades arguing, patiently, paper after paper, that the branches are real and that we must take them at face value, knowing all the while that the branches he defends can never be reached. Max Tegmark did the counting that placed the nearest copy at the end of that tower of exponents, and published it, and went on with his work. Alexander Vilenkin followed inflation into the eternal picture, and saw the endless ocean of pockets, and kept following the mathematics where it led. None of them stopped. That is the part worth holding. They looked at a universe that seals every observer inside an unreachable region, surrounded by unreachable others, and they did not put down their pens. They kept doing the work. They kept following the equations. They kept publishing the careful papers and teaching the patient students and building, slowly, across whole careers, a more honest picture of where we actually are. There is a kind of courage in that which has nothing to do with bravery in the dramatic sense. It is the quieter courage of continuing to look at something large and cold and true, and continuing to find it worth understanding, even when the understanding offers no company you can reach. The physicists have been carrying this weight for decades, and they have carried it not by denying it and not by being crushed by it, but by treating it as the situation they are in and going on working inside it. That word matters. Situation, the emptiness around you tonight, the unreachable branches and the unreachable copies, is not a measure of your insignificance. It is a description of your situation. You are a finite observer inside an enormous structure that is a circumstance, not a sentence. The vastness does not make you small in the way that matters. It makes you located. It makes you placed. You are here in this reachable region, in this room, on this branch, and the unreachable others are part of the geometry of where you are standing, not a judgment on whether your standing there means anything. A grain of sand is not insignificant because the ocean is large. The grain is simply where it is. The ocean is simply how big it is. The two facts sit beside each other without one diminishing the other. You are not made meaningless by the multiplicity around you. You are made singular by it. You are the one version of you who is here, in this place, having this experience, holding this glass, and that singularity is not erased by the existence of others you cannot reach. If anything, the unreachability is what makes this particular version, this here, this now, the only one that is yours to live. But we are not at the comfort yet. We are still in the quiet. Let us not rush out of it, because the profile asks us to sit here at the floor and let the weight be real before we lift. So picture the room one more time, the way it actually is. You are lying in it. The light is low. The glass is on the nightstand, or the hand is on the blanket. The air is still, and layered over this room, in the same space, are countless branches, countless versions of you who made some other small choice tonight. All of them as real as you, none of them reachable, none of them aware of you, each of them as certain as you are of being the only one. And far beyond this room, past a distance that cannot be drawn, in pockets of an ocean that has no shore, are the exact copies, living this same night, in this same room, receding from you faster than light, sealed away forever. You are surrounded, and you are alone. Both are true. We cannot call them. We cannot write to them. We cannot stand in the same room with them, though in one sense they are standing in this very room. We cannot know them, though they are, in every measurable way, ourselves. The company is total and the solitude is total, and they are the same fact seen from two sides. Hold that for a moment. Let the silence sit. Do not fill it yet. This is the floor of the night. This is the lowest, quietest point of the whole walk, and it asks nothing of you except to be here, in it, awake to it, for just a moment longer before we begin, slowly, to climb back toward the glass and the breath and the rest that is waiting. There is no message to send. There is no branch to confirm. There is no copy to reach. There is only this room and the low light and the weight of being one located observer inside something far too large to cross. Stay here a moment. We will not stay long, but we will stay long enough to be honest. And then, gently, in the last part, we will turn back toward the glass, and we will find that everything we have just walked through does not have to be carried as a weight. It can be set down. It can even, in the end, become a kind of comfort. The same facts, the same physics, the same unreachable others, seen at last from the one place you actually are. Hold the glass. We will turn the page slowly, and we will begin to come home. So let us come home. We have walked a long way tonight, out through the equation that refuses to collapse, out through the ocean that refuses to end, down into the quiet floor where the others, near and far, sit forever beyond our reach. It was a long walk and a strange one, and you carried it well. Now we come back, back to the room, back to the bed, back to the small thing you have been holding since the very beginning. Hold the glass. If there is no glass, then your hand on the blanket. Whatever you reached for at the start of this walk, reach for it again now. The same object, the same weight against your fingers, the same small, ordinary thing that was sitting on your nightstand before any of this began. It has not changed. Not a single atom of it has moved because of anything we said. It is exactly what it was, and it means something different now. Let us walk back through what it means, not as a list, not as a summary, but softly, the way you might run your hand over something familiar in the dark and feel, for the first time, everything it has always been. The glass is made of atoms. You knew that before tonight, but now you know what the atoms are doing. Their behavior at the deepest level we can reach is governed by the wave function, the ledger of possibilities that does not collapse, that only ever widens. The water inside the glass, the curve of the glass around it, the warmth your hand has left on its surface, all of it is built from particles whose stories are plural before they are singular, spread across possibilities, containing more than one version of themselves. And the wave function, read honestly, read without flinching, says that the world keeps splitting. So somewhere, in a branch decohered from this one, separated from you by nothing you could measure as a distance, the glass is empty. You drank it earlier, in that branch, and forgot to fill it again. Somewhere, in another branch, the glass is full to the brim, fuller than the one you are holding. Somewhere, the glass is not on the nightstand at all, because a hand, slightly less careful than yours, knocked it over an hour ago, and a different version of you is lying in a bed beside a small dark stain on the floor, thinking about something else entirely. All of these are real, not as possibilities you avoided, not as things that might have happened, as things that are happening right now, in branches as real as the one your hand is resting in. The empty glass is real. The full glass is real. The spilled glass is real. They are all real in exactly the sense that the glass under your fingers is real, which is the only sense of real that the physics knows how to offer. Hold that for a moment, and beyond the branches, past the undrawable distance, in the pockets of the ocean that has no shore, there is a glass exactly like this one, the same water, the same curve, the same warmth from the same hand, a copy of this glass in a copy of this room, beside a copy of you, on a copy of this night, receding from you faster than light, sealed away forever, and yet there, holding the same water you are holding, in the same quiet you are sitting in. This is everything we built. The branches in the room, the copies in the ocean, the unreachable neighbors who share your past or your shape. All of it is true, as far as the physics can tell, and all of it is gathered now, in the small weight of the glass in your hand. Now let us soften, because there was a question underneath all of this, and we never quite answered it, and it is time to answer it, the way the whole walk has been quietly answering it all along. The question was what to call them, the other versions, whether they are you or not you, or family, or strangers wearing your face. We turned that question over carefully. We found the physics could not settle it. We found that wise people had thought about it for a very long time and concluded that the answer is not a discovery, but a decision, that the line between you and not you was always something we drew rather than something we found. So here is the answer the walk has been offering gently the whole time. The other versions are real, yes. The branches and the copies and the neighbors, all of them real, in the only sense that matters to physics. And the other versions are not reachable. Also, yes, not one of them, not ever, by any means, the universe allows. Both of these are true, and they have been true together since the first part of this walk. And what follows from both being true is not loss. What follows is this. What is left for the version of you in this room, on this bed, tonight, is this room. This bed, tonight, that is not a small thing left over after the large things were taken away. That is the whole of what any version ever has. The copy in the distant pocket has only its room, its bed, its night. The branch that split from you 10 minutes ago has only its room, its bed, its night. Not one version anywhere in any branch or any pocket has access to more than the single life it is living. They are all exactly as located as you are. They all have exactly one room. The multiplicity does not give any of them more. It only tells each of them that the others exist unreachably, living their own single lives in their own single rooms. The multiverse does not diminish the single life. It frames it. It places the one room you have inside a structure vast enough to make the having of it precious. The fact that there are countless versions of this night does not make your version less real. It makes your version the only one that is yours. The empty glass and the full glass and the spilled glass are all real, but they are not your glass. Your glass is the one your hand is on. The copies are all real, but they are not your night. Your night is this one, the one you are in, the only one you will ever be in. You are one of infinitely many. You are also the only one in this room. Both are true, and the second truth is not erased by the first. If anything, the first is what makes the second shine. In a universe generous enough to contain every version of you, the version that is here, now, holding this glass, breathing this breath, is the single, irreplaceable point from which your life is actually being lived. No copy can live it for you. No branch can reach in and take it. It is yours entirely, precisely because all the others are sealed away in their own rooms, living their own irreplaceable nights. So let us be here, fully here, in the one room that is ours. Hold the glass. Feel the weight of it in your hand, the real weight, the actual pull of it against your fingers and your palm. This is the most certain thing in the entire picture we have built. Not the branches you cannot detect, not the copies you cannot reach. This, the weight of this glass, right now, in this hand, the one thing in all of it that you can actually touch. Feel the temperature of it, the coolness or the warmth where your skin meets the surface. Let your attention rest there on that small, honest contact, the place where you, the located observer, meet the world you can actually reach. And now, gently, let the glass go. Set it down or let your hands settle back onto the blanket. You do not need to hold it anymore. You only needed it to find your way back. Listen to the breath leaving your body. That is yours too, the most yours of anything. Not a copy's breath, not a branch's breath. This breath, leaving your body now, in this room, on this night. Follow it out. Let it go all the way. And let the next one come on its own, without effort, the way it always has. Somewhere, a version of you is doing exactly this. Lying in a slightly different room, following a slightly different breath, on a slightly different night. They are real. You will never meet them. And there is nothing in that to mourn. They are well in their room, as you are well in yours. Somewhere, a version of you has already let go, already drifted, already crossed over into sleep. In a room very like this one, on a night very like this one. They went gently, they are resting now. Let that be a comfort, not a weight. You are not alone in the largest sense. Even as you are entirely alone in this room, on this branch, in this single precious life, The universe was generous enough to make more than one of you, and it was wise enough to give each of you a room of your own, a night of your own, a breath of your own to follow down into rest. You do not have to reach for any of the others. You do not have to wonder which branch you are on. You do not have to cross the distance to the copies in the ocean. There is nothing to solve tonight. There is nothing to reach. There is only this room which is yours, and this bed which is yours, and this breath which is yours, carrying you down slowly into sleep. So let yourself be held by it, by the geometry of a universe too generous to contain only one of you, and too vast for any of you to be anything other than alone. And somehow, in that strange arithmetic, exactly where you are meant to be. One located point of warmth in an enormous quiet structure. Here, now, real, yours. The same glass that opened this walk has closed it. The same hand, the same room. Nothing has changed, and everything has. You are one of countless versions, and you are the only one here, and both of those are a kind of company if you let them be. Rest now. The same room holds you. The same breath carries you. The same body here on this bed is the only place you need to be. There are other versions of you somewhere beyond all reach. Let them go. Let yourself stay. Sleep well.